had a question about textbook problem 30.43, and this is one where we have an electron is moving in orbit about a proton, and they tell you what that radius of that orbit is. It's the Bohr radius, which they give you the number from the book. So we'll call that R. And they want you to find the frequency and some other things regarding to this atom. So this is the kind of question that's really, in a lot of ways, more of a 131 question. So we take F equals ma, and the force, this is the new stuff that we're doing. Our force equation is K times Q1, Q2 divided by the radius squared. That equals m. Now this electron, if you look at it as a classical picture, is moving in an orbit. And so it's going to have centripetal acceleration of v squared over r. Now what we can do is use this equation, if you remember from rotational motion, the viewer equation. And even further so, I know that omega is equal to 2 pi times the frequency, okay, which is just how many oscillations, or in this case, how many revolutions there are per second. And so I can plug this into here for the velocity. So if I do that, I get m. And then I plug in, so 2 pi, the frequency r squared divided by r. Over here, I realize that the charges is the charge of a proton and the charge of an electron, which is just E, where E is our little charge number of 1.6 times 10 to the negative 19 coulombs. And this mass here is the mass of an electron, which you can look up, which is something kind of like this here, if memory serves. And so we've got everything we need to go through and solve now for this frequency. So r squared, now once we clean this up, it'll be m 4 pi squared frequency squared. Now this will be r squared divided by r, so it'll just be r. And if I go through and solve for this frequency, I get something looking kind of like this here. The r cubed on the bottom, m 4 pi squared, all of this, the square root of that. You get your answer for frequency from there.